Alright, welcome to Meteorology 101. We're going live. Let's get a look at this radar. Got about, let's see here, 20 or so severe thunderstorm warnings all the way from Mississippi, Oklahoma, Louisiana, Arkansas, Texas, all the way up to North Carolina and Alabama. We did have some severe thunderstorms in tornado warnings in North Carolina and Virginia earlier. All that has expired. Let me refresh this thing. Warnings all throughout Mississippi, Louisiana, some through Arkansas, right along the state line there. Make sure I'm live here. Okay. Alright, let's see what's going on. Let me get my radar downloaded. Right, first, I'm gonna go to the charts. We're gonna pull up. We know we got warnings everywhere. I want to see what's going on with the Synoptic situation. Okay, so I'm gonna pull a surface chart. Alright, we have low pressure over Texas, centered over Texas. That's moving to the north. That's part of that system, that parent system that moved to the north already. The frontal system, pretty much this low pressure system developed off the that decaying wave. It was pushing up to the north. We had that front that was pretty much stationary, causing all that severe weather in Arkansas yesterday. And then with the onshore flow from the subtropical high pushing all the moisture right along the Gulf states, just pumping that moisture, and that's still what's happening now. And then as this low pressure develops, it is a baroclinic system, so we have warm air advection from the south. As that pushes to the northeast, then we will start seeing even more severe weather through Arkansas, Alabama, all the way over to Georgia. Here are the surface plots. So if we look at the plots here, we can definitely see convergence over Oklahoma, northeast Texas, the onshore flow over Louisiana, and then looks like some divergence over Arkansas. So let's go over to the radar and see how this is playing out. Actually, let's go to the upper levels real quick. I want to see what kind of upper level support this low has. And let's take a look at what was going on in Virginia, North Carolina. Looks like a little, maybe just a minor shortwave right there in North Carolina. But that's pushed off some troughing, just right there, troughing into that high pressure system. So just a little unstable wave moved through, just enough to cause some severe weather right along the North Carolina, Virginia line. I'm gonna do a pressure. We'll do a balanced height on this. See if we can get some systems pulled out. When we do the balanced height, that kind of averages things out on the contours, and it actually will detect a little bit smaller systems, smaller features on these charts, so we can maybe see what's going on over there in the east. So there's the low pressure to the north. We got this will be low pressure, pretty much troughing all the way through the central United States, and then some ridging. Like I said, maybe just a minor shortwave move through North Carolina and Tennessee. Let me go back here and just pull the regular height on this thing. So we do have the low pressure there, low pressure there. We got high pressure ridging through the northeast. That's not really correct. We got troughing all pretty much all through the eastern United States. So a little bit of weak convection. That's probably what's moving through that with that trough moving through North Carolina. We had a little bit of unstable wave right through there, and that was causing that tornado. This is pretty much becoming barotropic. The low pressure system, we still have support down in the south. With that low is a closed low at the 850. So that's a pretty good, pretty strong system there. And then the warm air advection is pretty weak on the 850 here. So upper level support's not too great. But if we pull the station plots on the 850, we can see what kind of winds we got. We have some 30 knot winds over Arkansas, 25 over Mississippi, 15 and 20 over Louisiana. So let's get a let's go over to the radar. We can pull up a vertical wind profile and get a better look at these storms that are going through. All right, probably everybody and their brother's downloading data right now, so it might be a little bit slow. It's pretty much most of this data comes from the same source. It's only a couple sources that the radar data comes from. So let's go over to Virginia real quick. Let's see if we can pull something up there. We still have severe thunderstorms in that area. North Carolina, Virginia, Boyden, Jackson. Looks like 2.73 inch hail indicated by radar. Northern North Carolina. And for some reason I'm not getting any data. Let's see here. We're going to turn the radar on. Okay. Alright, now here's that cell over Jackson, just southeast of Jackson. 2.73 inch hail. That's pretty intense. So let's go look at that. Do a cross section on it real quick. See what that's pretty much reaching all the way to the surface. So high reflectivities all the way almost up to 30,000 feet, 50 dBZs all the way to about 35,000 feet. So we're pretty intense there on that updraft. You see the anvil, the overshooting tops over 40,000 feet. So we are, that's a pretty intense cell. I wouldn't be surprised if that didn't, once they start showing rotation, go to a tornado warning. I don't see any major hook echoes. I mean, we do have some inflow here around this cell. Let's get a, we can do a volume scan on that. Now we can cancel out all the lower dBZ. Still well developed in the upper levels, all the way to 40,000 feet. Now, let's go all the way up to the 50 dBZ. You can see you definitely have an updraft, maybe even a downdraft there. So we're doing pretty good on that storm. Like I said, I wouldn't be surprised if that went to a tornado. We can outline that a little bit. See if we can get a better shot at our lower levels. Lower reflectivities, we can go all the way to the center of this storm. And then we can look at rotation. So here's the lower reflectivities. You can see most of that core is more intense. This is just right here is 10 to 20 dBZ. Get up to 20 to 30. 30 to 40. And 40 to 50. And then once we start dropping down 50 to 60, now you can start seeing this little curvature right here. And we still have some pretty intense reflectivities all the way up to 30,000 feet. So, like I said, I wouldn't be surprised if that wouldn't go to a tornado. Let's see what kind of rotation we have in this storm. And we got rotation pretty much, not quite at the surface, but about 5,000 feet and all the way up to 40,000 feet. So Let's go back to the radar. We can put some station plots over here, see what weather stations are in the area. And then we can see what kind of bases we're looking at. So, yeah, I didn't want to do that. Just a second. Get my pointer turned back on. Pull that down. We can get a better look at this. I got a pop-up window that says heavy rain, 2 miles visibility, scattered 2,000 feet, broken 3,900 feet, overcast 5,500 feet. So our ceiling's at 3,900 feet, right around Halifax. So that's these bases. You know, we got scattered clouds at 2,000 feet. So, you know, the base of this thing would be pretty much 2,000 feet if that cloud level is accurate, which it is, I'm sure it is, being from a weather station. So if we pull this up, we can look at that. We're pretty close to that surface, so get a better look at this. Okay. Let's do a cross section on that again. See that higher reflectivity is okay. So now the base of this thing with what the radar's picking up is right about 5,000 feet. We know that drops a little bit lower than that. So we was at the ceiling was at 3,900 feet, scattered to about 2,000 feet. So there's a pretty good chance that drops to 2,000 feet. But that's a pretty strong, intense core right there. Let's see what get a big longer shot on that. Let's go 3D again, and we can pull up. Let's see what kind of anvil we're working with. So we do the full. There's our overshooting top, 40,000 feet. There's the anvil. So this thing, let's go look at the direction that it's moving. You can see the wind. There's upper level winds at the tropopause. When this goes up, hits that tropopause, it overshoots that stable layer right where it becomes stable at the tropopause, and then the winds, whatever the wind direction is in the upper levels, is the direction of that anvil is being blown off, the cirrus blow off from the top of the thunderstorm. So we can put this in motion. Get rid of my warning. Let's go. Download the latest loop. Alright, so we're moving pretty much to the southeast with this one. So anything in that path, if you're in Woodland, Outlander, Powellsville, I mean, keep an eye on that stuff. Listen to the news, turn on the weather station, weather radio. Should have a weather radio for a backup with batteries. So in case your power goes out, you can keep up on these storms. So we got, so you can see the severe warnings just coming and going. There's the tornado warnings we had earlier, right south of Halifax, and then that all canceled out. Like I said, I wouldn't be surprised if this cell possibly doesn't go more severe. I mean, it died out a little bit, but it's kind of back and forth on its intensity, and you can see the higher DBZs right there at the end. You're pushing over 73 DBZs right there, and let's get a velocity on this thing. I mean, if you look at the radar here, where our radar's to the southwest, and then in that storm, you can see the areas where we have incoming winds. All the green is incoming, the red is outgoing. So you know, you can see there's small areas of rotation. So, like I said, I'm kind of surprised they're not going to go with severe. I mean, 1.82 inch hail, that's a severe thunderstorm, but with the rotation, I mean, how intense it has to get for them to call a warning, I'm not sure what they're looking at there. I mean, I was a forecaster out here at Cherry Point, North Carolina for 2 years, right in Havelock, and if I seen something like that, I would definitely be, my warnings would be set. I mean, I was in Cherry Point, so, you know, obviously up there, I wouldn't be setting warnings for Cherry Point, but you know, if I seen something like that coming my way, there would definitely be warnings. The warnings will be noted, and you know, no aircraft will be going in that area. So let's get my let's go vertical integrated liquid. I mean, we're pumping up pretty high on that. I mean, we're at 46.2 kilograms per meter squared. I mean, you're cranking pretty high on that. Let's go to echo tops here. how high is this going? 42,000 feet. So, I mean, with that hail being that intense, this is definitely a hail maker. I mean, like I said, I'm not sure. I know definitely severe, but definitely keep an eye out for a tornado warning there. All right, let's go down. Let's see if we can get back down into Louisiana. Let's go down there and see what happens. Tons of warnings all through Louisiana, eastern Texas, southern Arkansas, and then eastern Mississippi, all the way over to Alabama. So there's multiple warnings. Let me see what how many warnings we have active right now. There's 30 active warnings right now. So let me get rid of their station plots for now. We get make it a little bit cluttered there. All right, here's a pretty intense cell. Bastrop, Collinston, Oak Ridge, right over Oak Ridge. Then indicated by radar, it looks like a 2.33 inch hail. So in a severe warning. This is valid until 7:15 Central Time. So about another 45 minutes or so. So hazard 2-inch hail, 70-mile-an-hour wind gust, radar indicated. Alright, so let's do a cross section on that one. Well, you see when you get up to 50 dBZs above 10,000 feet, you can have a severe storm. We're cranking all the way up to 40,000 feet here. And then we get into the 60 plus dBZ up about 34,000 feet is where that is. You still see the updraft. It does have a tilt at the storm. And then let's go. Looks like the blow off there. We can go do a volume scan on that. That's the lower dBZs. There's not a lot there, way in the upper levels. Then bringing down into the lower reflectivity, you can see the center of the storm just pretty intense. There's the 50 dBZ reflectivity, 40,000 feet. And we can go all the way down to the 60 plus dBZ. And there's the structure of the 60 dBZ or higher. So pretty intense updraft. So let's go. There's the whole entire structure. Okay. And we can always back that off as we want. We can pull up whatever layers in a transparent form. So we can see the upper layers there, just in a little cloud looking visual, just give you an idea of that structure. So this rotation we want to look at too. And there is pretty significant rotation throughout this storm, all the way up to 30,000 feet, down just below 10,000 feet, showing that rotation. So the base of that rotation probably isn't low enough for it to be on the surface, so while we're not in the tornado warning there. Let me get rid of that. I'm going to do a cross section. Probably a little far on that one. Let me zoom in. You can see the structure, the high intensity updraft of this thing. You know, like I said, pushing, 37,000 feet on that 50 dBZ line there. So, all right, let's go look at a loop on that real quick, and just pretty much moving to the east, northeast. what we can do here is we can get to the last screen, back up a couple. Let's back up a few, and then we can pull that cell. Let's place a marker on that cell. Then we can go to the last screen and then put another marker on that cell. Actually measure from that. We can do a storm motion from marker. 240, 38 knots. And then place, let me get this out of here. Let me get rid of that hail. Okay. Now we can place a storm track. So in an hour, that center of that storm will be right there. Let's see, get my pointer straightened out. So Gasaway, just northeast of Gasaway. That's where that cell will be. Now we'll keep an eye on it, see how it intensifies. Let's go ahead and put the station plots back. See if we're getting any gusts out there ahead of these storms. Right now is a thunderstorm right there. Winds are 310, 12 knots, gusting to 15. And the ceiling's at 5,000 feet. There's a thunderstorm in the area, obviously. And broken at 5,000, broken at 6,000, overcast at 7,000. So base of those storms, 5,000 to 7,000 feet. Base of the clouds. Probably, you know, anybody looking at that right now, if it's dark out there, they're not going to be able to see a lot. Visibility is going to be low. Looking up in that skies, they probably got an ASOS shooting the beam up, telling them what those layers are at. See what else we have. Here's a station right there, and we are gusting to 38 knots. We're at winds are out of the northwest, 22 knots, gusting to 38. Vicinity thunderstorm, light rain, few at 3,600, scattered 7,000, overcast 11,000 feet. Alright, so Mississippi, let's see where we're at here. That is a Mississippi there. We can pull up other storms in Mississippi too. Let's go, let's move one radar over. Download the loop. We got temperature and dew points. We're in the dew points here to 64s, mid 60s. So, you know, this is all good data for severe thunderstorms. So anything that pops up, you know, any of those cells that pop up are most likely going to be severe. So, with the dew points at those levels. Here's one around Carrollton, and this is Alabama. Let's get a good look at that one. It's just a small cell, but it's out of the warning area. But it's got a higher reflectivity, about 63 dBZs. And it's out of the warning area. It's a little bit to the south, so let's do a cross section on that. Alright, so our radar reflectivity is a little bit off. We have to kind of catch it with this cross section. Sometimes the cross section and the radar don't agree because it takes about 6 minutes to download this data and process it. So what you're seeing on the screen can be just a little bit off. Let's swing that over. We've seen some purple one there. I'm trying to catch that. So see where we need to be. To the south of that. Let's see. I think we're getting worse. Guess we're not going to catch it on that. It's probably most of that high reflectivity closer to the ground where we're not seeing it on the cross section. But we can see the upper levels. Got the updraft. This is showing only 10,000 feet. Here, let's do something else. Go to the radar real quick, and what we can see also, I can go up in the upper angles of the radar, and you can see it just disappears. So once we get about 3 or 4 angles up, about 2.4 degrees, that thunderstorm's pretty much gone. I mean, not that to say it's not intense, but because we are shooting up to 50 dBz, almost 20,000 feet, and then our heights of that thing is almost 40,000 feet. So by no means am I saying that's a weak thunderstorm, but we start pushing up into those upper levels on that radar, and that just starts to get a little bit weaker. What I like to see is where, if you watch one of these thunderstorms where the excuse me a second, where the get my pointer, where you can see the anvil, then you can go up in the upper levels on that radar, and you can see that storm kind of move over, and you can see the intensities when you get that angle of the updraft. As you go up into the upper layers of the radar, you can see that reflectivity is moving usually to the east, and shows you the area of your lift, of the angle of your lift, and the blow off from the cirrus on the anvil. So, and then we'll do a base velocity. See, there's a lot of it's all red. That's means just moving away from the radar. So the radar is down here. So all that wind is pushing to the northeast away from that radar. We got this green coming in. That's in toward the radar, and then the red is out. So this is kind of pushing. Right there's a wind barb. That's from the southeast. So pushing out away from that radar. Once you start seeing the lighter colors coming in toward the radar against that red, then you can look for some gate-to-gate shear and some, to indicate any kind of rotation. The idea, we like measure the width of that green and the red, how far apart they are. And, once you get up to a mile, it'll be about the biggest tornado that you could really have, about a mile base, and then anything over that's just going to be more or less considered a cyclone. Alright, so here's a pretty intense storm, and this one is over here in Louisiana. This could have some pretty good winds right ahead of that. 10 knots to the back of it. I don't see any station data. Clear. There's clear skies. I doubt that's right. It looks like that says auto, so that's probably an ASOS, and it's not picking up anything. Here's a rotation just popped up. So, excuse me. Let's go do a cross section on that real quick. And then the rotation just went away, and a hail just popped up. I've seen that, like maybe what was like a meso. So we do have an angle on that, and then you can see the blow off there. So all the way up to 30,000 feet, and then so we got a pretty good angle on that storm. So if we go up on the upper elevations, that hangs out there for a minute. Actually, we get into some higher reflectivities right there. Let's cut that in half. Right there it is. So now you can see the higher DBZs right around 10,000 feet with 65, right around 60 DBZ, and then the 50 shooting all the way up to the about 30,000 feet, and then you're getting your overshooting tops at over above 40, and then your blow off right around 30,000 feet. And then we can do a volume scan on that one. Alright, so we got everything cut out except for the 50 dBz, so we can throw everything back in there. Now you can see your cell well into the upper levels. I've got a pretty big scan right here, big section I cut off, so I'm going to do a little bit smaller than that. Let's see if I can hit that over here a little bit better. Now cut out all the lower end stuff, and then start seeing the heavier structures of the thing. Alright, I'm not doing any chats right now. Let me see if I can Trying to see what you guys are seeing, if anybody's watching. Average watch time is about 4 seconds. I've been going for 30 minutes, so hey, thanks for watching. It's all good. Be something to come back and watch. Hoping you guys can hear me. I guess I should stop this video. This is my first live stream, so I don't know if I'm screwing this thing up or not. One playback. Alright, so I'm gonna go ahead and end this thing. So I doubt that I'm doing anything. I'm showing 30 minutes in, but I'm not so sure what's going on. So I'm gonna end this video right now, and I'll come back in a little while if once I perfect this live stream thing. Thanks for watching, and please subscribe.